We are a little bit late already, so I guess it's good to start the meeting right now. I am Jürgen Rauschenbach from DFN Germany. I'm the session chair. And well, what I want to say as an introduction is that having a session about NOx is new at the TNC. So we had the idea to try to bring different models of NOx here into the presentation, also to show what is similar things the NOx are doing and what are the differences. And of course, you also will get the chance to ask some questions. Actually, the idea was to have it as a panel discussion. As you can see, it's a little bit difficult to have a panel here. If you don't want that our NOC guys are standing on the stage all the time, it will be not so convenient. So what we are doing instead then is to have the presentations one by one. We will have a possibility to ask 2 or 3 questions after every presentation, and then we can have hopefully, if some time is left, what I think that we should be able to make, we can have some more discussion at the end, just asking any of our 4 presenters. So we will start with Dirk Hex from Belnet. He is the head of the network department in Belnet, and he will give us presentation about what the main tasks are there. And then we have actually make the proposal to have a more general part of each NOC presentation, and then we provided the chance to select another item that is kind of in the special interest of the NOC to present here. So the second part of every presentation will be different. The first part should give a little bit in general and common basic, so that we can also compare some things. So that's all. Let me just repeat that I want to welcome you all to the session. Please, at the end, don't forget also to fill in the evaluation sheets. What is quite interesting for the program committee, of course, is, and well, if I'm looking at the auditorium, it's quite a few participants. I'm really happy about that. So obviously the idea is received well. But if you want to like similar thing at the next TNC, you should also make just a comment on that. That would be helpful for the program committee. So enough. We don't want to lose more time. Dirk, please, you are the first speaker, and I will say a couple of words to the others when they are then on stage.
Okay. Thank you. Good afternoon, everybody. So I have the honor to start this NOC panel discussion with the presentation from Belnet. This is the title of my presentation, and I hope it will be clear after my presentation what I mean with take nothing for granted. So we have streamlined the Belnet help desk recently, and the goal is to go much more in detail right now. So when we look at the agenda for today, I have 3 parts. Before I go into the details of our help desk and NOC evolution, I will present Belnet in a nutshell to see which networks we are maintaining today. Second part is, of course, the help desk and NOC evolution. There's an important evolution been made the last years, the lessons learned, and our current approach and tools we have. And then, like just said, the area of interest that I have chosen is scripted change management and the relationship with our NOC. Okay, let's start with Belnet in a nutshell. Last year in 2008, we celebrated the 15th anniversary of Belnet. And in those 15 years, a lot has changed. We have now more flexibility, autonomy. We have more employees. For your information, we started in 1993 with 3 people. Today we are approximately with 40 people, and normally end of this year 49 people. So huge increase. We have, of course, like you, more bandwidth and resiliency, more networks and services. I will come back to that later. And also important, we made a shift a few years ago from focused on the technical part to a more customer-oriented approach. There is one but. We are a government organization, and within Belgium, we don't have opportunities to let our people, our network engineers, our engineers work out of office hours. And of course, this has an important influence on the choices made by Belnet concerning the 24/7 service. This slide very fast to show you that the current helpdesk and NOC 24/7 is managed by the network department of Belnet, but of course has a link with both the network and the services department within Belnet. I will not spend a lot of time about this as time is limited. Okay, our current Belnet network, it's a hybrid network. We have 4 optical rings. We have 1,560 kilometers of fiber. And in the middle of the drawing, you see the 2 core data centers. I will come back to that later. We have in total 35 ROADMs, 4 core routers, 2 per data center, 33 access routers in our POPs, and in total 63 10 gig connections. We have 21 POPs today, approximately 192 customers and more than 650,000 end users. Okay, on top of that, we have a dual IP star network built via our optical network. And you see that the 4 core routers have both a function towards the external world, connectivity towards the external world has been divided over the 4 core routers. And also, of course, to aggregate the POPs to make the dual star, of course. I don't know if everybody is aware, but Belnet is also responsible for 2 other networks. So in 1995, Belnet created the BNIX, so the Belgian National Internet Exchange. You see there the details, the current details as we speak. And in 2002, a third network, the FETMA network, was built by Belnet. This is the Federal Metropolitan Area Network, so specifically built for the federal government in Belgium. And the goal is, of course, to interconnect all the federal departments to each other and centrally to the external world. Okay, Belnet in a nutshell. You see now that we have 3 networks. Also important to say, we have put a lot of resources into the design to make it very reliable and performant. So when we have incidents, to avoid downtime. Okay, let's start with the evolution of the helpdesk and NOC. Like I said, we started in 1993, 3 people. It's a long time ago. It was the time of 64 kilobits per second backbone. At that time, the network was very easy. We had a few POPs, a few customers, no complex technologies like today. And in fact, at that time, there was no monitoring at all of the network. So when there was a problem, a customer called Belnet during business hours. And then at that time, we logged into the routers to find the problem. But it was a time before telecom liberalization, so the internet was more down than up. And so our customers, they liked it because it was at that time no problem. So it was the case a very long time ago. Some time ago, and this is the famous year 2002, and of course the internet boom. Okay, there were already some changes because at that time everybody wanted to consult the internet. There were business-to-business applications, so there was a more professional demand from us. And so our answer to that was, okay, the backbone needs to be available all time, so we need to outsource towards the commercial market a kind of watch service. And goal of the watch service is in fact to monitor the backbone lines and the routers. And when there is a problem, to trigger the different parties involved, telecom operators or the integrator of the network. Like I said before, we don't have the manpower nor the possibilities to let our people work at night during weekends, so we needed to go to the market. So the difference was we had something in place professionally to have a reliable service on the backbone level, but our customers didn't have the opportunity to contact us 24/7. It was only during business hours that the customer could have contact with Belnet. Okay, in 2006, a major step, like I said, the Vetman network. Okay, the Belgian government, they have asked us very, very high requirements. One of the requirements was, okay, we want, first of all, that the federal department can have always contact with the help desk 24/7 via phone and mail. But also a second demand was, we don't like changes during office hours. We would like have the opportunity to do changes during night, during weekend, outside office hours. Okay, again, regarding our statute, we have outsourced here a complete NOC towards a commercial third party on the market in Belgium. So both help desk 24/7 and NOC were outsourced, and incident and change management. In fact, we can see 3 layers in that. When a customer has a problem, he contacts the help desk. Help desk are operators, open a ticket, trigger it to the NOC, and in case of problems, very difficult problems, there is always an escalation path to Belnet. This is an example. This is the NOC, and as you can see, it's a professional NOC today for the Vetman, and our requirements were very high. So one of the things, very high requirement, was the transparency. So in fact, when a federal department calls our NOC, our help desk, they will act as Belnet. So they will take the phone and they will say, okay, hello Belnet, what's your problem? Other very important thing is the service level agreements we have with them. So penalties, very important. Also reaction time, very fast, 15 minutes. A ticketing system, a NOC, all is included in the solution. Okay, very important, I think, which lessons were learned concerning the incident management. Was this an added value for Belnet? Of course it is, because we don't have the opportunity to manage it by Belnet. But we have learned quite well. Very important is that you have clear procedures between your organization and the third party. What I mean with that is clear procedures, up-to-date information for the third party, and so on and so on. The second thing that's extremely important is that the customer is key. What I mean with that is, in the past, when a customer contacted Belnet, he was directly in contact with the third line Belnet network engineer. So, we don't have that many customers, so we directly could pinpoint to the problem into the routers. Now, when you outsource it, it's completely different, because somebody who has no emotional band with the customer picks up the phone, and he don't know the customer by heart. So he needs to there needs to be a solution in place to solve that problem. And we solved it by our CRM, and every customer has an acronym. And with that information, the customer contacts Belnet, gives his acronym, and all information from the customer, all details are visualized via a web tool. Also important is the close follow-up, and not only the 24/7, so the discussion every month, the SLA reports, face by face, that's not enough. What we see is that you need a day-by-day close follow-up of the different NOCs. So very important that you do that. Also, today, ICT collaboration tools are key, and they are there, so use them. For example, we use Jabber to discuss very fast with our NOC engineers that are not in Belgium located, but in the Netherlands, for example. So use the tools that are available. And then, last but not least, beware of pitfalls. Like I said, the customer is key. That's a very important one. but also the fact that the feedback time is will increase. Like I said before, in the past, during business hours, a customer contacting Belnet, he was directly in contact with a third line engineer. Here it's not the case. You need to pass via an operator. The operator will escalate it to the NOC. So this takes time, and you need to give that message towards the customer. Okay, concerning change management, lessons learned. Is this an added value for Belnet? Well, not really. Let me explain. First of all, when you outsource your change management, you need also for all different kind of changes, procedures. This takes time to first set them up and afterwards to follow them. This means what we saw is when you outsource your change management, the time that is needed to fill in all the paperwork, at that time, you do it better by yourself. That's what we saw. And for that reason, we insourced recently the change management that we outsourced in 2006. Another reason why we can do it is that the request to do changes outside business hours, it's rare. And so at night or in weekends, we don't see a lot of changes. So what we do today, we are flexible. Sometimes there is a question to do it very early in the morning or late in the evening. For those little demands, we are flexible and we do it by ourselves. So outsourced change management for us, not really an added value. And in fact, there are also some dangers to do that. First of all, your reputation, because we have seen cases where implementations were done by so-called experts, but in practice it was not best practices that were implemented. And also, that's also very important when you outsource your change management, you lose hands on your networks, and some employees can have problems with that and can leave the company. So be careful with that. Okay, today, for our 3 networks, how are we working? So we have our incident management that's outsourced and transparent. So they are working for Belnet. It's 24/7. They are reachable via phone and mail. And it's based on a 3-layered model. So help desk, NOC, and then Belnet in case of very complex problems. Change management, support and advice, it's all inside the house, Belnet. Business hours, but like I said, there is flexibility. Phone and mail, and the advantage, very big advantage, there is a direct contact. Okay. Concerning the incident management and outsourcing, it's very, very important to, from day one, to communicate your streams, your procedures, your flows towards your customers. And therefore, we have created, this is an example of a leaflet we created and has been sent to all our customers. In fact, it's a summary of the different procedures to follow, and it's not visible here on the slide, but the acronym of the customer is also printed on this leaflet. This is an example of the collaborative tools that we are using to create the procedures so they are visible to everybody. We are, in fact, the owner of all procedures, and the NOC people need to follow them. They are here visible on this portal. Okay, very fast, the tools we are using. Okay, we outsource the incident management, so the monitoring of the network is included. But this does not mean that we don't have our own tools inside. We are using mainly MRTG, Nagios, and the Junoscope software of Juniper. Of course, also our network management system for the optical network that's not mentioned here. And then the NOC, the different NOCs we have in place, they are using commercial products like you see there on the slide, EMC, so Voyance, Micromuse, it's now Tivoli, and HP OpenView. Okay, I will show you now the flows in place when a Belnet customer has a problem. Today, this works like this. So, 24/7 help desk can be called 24/7 or can be contacted via mail. if possible, of course, based on the incident. Okay, first thing that the operator will do at the help desk is consult the CRM. So based on the acronym given by the customer, and all details are visualized via the tool. They will listen to the customer, they will create a ticket where they put all information in, and the ticket number is back to the customer. And then, if it's a network-related problem, the NOC is informed. They will check the tickets, they will update the ticket, and every time a ticket has been updated, the help desk will update the customer. That's very important, the feedback, like I said before. Okay, of course, there's always an escalation path to networks when they are in doubt, when they have questions, they will contact Belnet, the network department, in that case. If it's a service-related problem, okay, the help desk will then also create a ticket, of course, and then contact the services department of Belnet. They will update the ticket system, and every time a ticket has been updated, the customer will be updated. Okay, of course, there can be a problem that's not been seen by or not directly seen by the customer, and then we have our monitoring system in place to monitor both the optical and the IP network. When there is a problem detected by the monitoring software, a ticket is automatically made, and when it's not a backbone-related problem and the customer has impact, we will proactively contact the customer if he didn't see the problem. Okay, conclusions for this help desk and NOC evolution. We saw a tremendously change in expectations from our customers. I think I illustrated that 1993, 2000, 2006, and today. So today, connectivity needs to be there all the time. It's a commodity. There are also new business models in place. We can't afford that the customer can contact us only during business hours. But, very important message, take nothing for granted. It's not trivial to set up a 24/7 organization in your own organization. You need to anticipate the workload, and very important, and therefore we are here. Talk with your peers, that's also very important. And we are here, so some people from Belnet and myself, we are here, hold a conference, so please visit us. We are available to discuss this in more detail. Okay, to conclude now, the area of interest that's also related to our NOC, not directly but indirectly. We use, since our new network, some automated configurations. In practice, we created the BGP full mesh and the MPLS LSP full mesh with some scripts. I will come back to that a little later. And also for our change management, that's, like I said before, in-house. It's based on scripts today, so both for IP services and point-to-point Ethernet services. Okay, an example and some advantages. Let's take a Belnet customer that is where we do the routing on a static base, static routed. Before, in 2007 and before the scripting, it was a manual configuration. We needed to create a lot of different instances on the router. And as you know, we are all humans. Mistakes, upper, lower case on descriptions, that's sometimes a problem. And it's also a problem for your automated NOC tools. We have scripts automated by NOC for our Nagios and MRTG based on descriptions, for example. Now it's all scripted. The whole configuration is on one line. And here you see an example from a customer. This is a concrete case of a customer of us, the KH Leuven. You see on the line that the first thing is, okay, we will implement a new customer. He's in the category research. We have different categories of customers. Next, here you see, is the commercial bandwidth. We are rate limiting our customers on commercial bandwidth. The interface that has been assigned to the customer, the point-to-point range, here the type of routing, static or via BGP, and then the prefixes. So, for example, this line, I've taken a look this morning. This line, this single line, creates automatically 73 lines behind the scene. For a BGP customer, it's even more, it's 103 lines. So, and everything is consistent and so on. So we are using Juniper routers, and if you have questions about that, you can also see Belnet for some examples. Okay, to conclude, what are the benefits? Single line concept, automated configuration. It's uniform and consistent here is very important. You have everywhere the same syntax. It's very efficient, and to give you an example, so last year we migrated from the old Belnet network towards the new hybrid Belnet network. Every network engineer was very happy with this concept because it was very efficient for the migration. And you also detect config anomalies before you implement them in real life on the network. So the direct implication, positive implication, is that you have a smooth integration with your NOC tools. So this was my talk about how Belnet has changed over the last 15 years, and then especially for the help desk and NOC. So if you have any questions, I'm here.
Nicely done, Dirk. We may have time for one question, if there's any really urgent one. Otherwise, we just put the discussion to the end. Is that okay?
You can think about questions like you said. We can do it at the end of.
Okay.
Okay.
Thanks
Thank
again,
you.
Dirk.
Okay.
Next speaker will be Toby Rodwell. Being a member of the Navy and a commercial company some time ago, he joined Dante 6 years ago, and many probably know him from the Giant2 project, where he was the coordinator of the service activity for multi-domain services. And now, close to 1 year, he is leading the NOC. Is it correct?
Yeah,
getting 1 year in July.
Yes.
So, and you will learn more about ticketing systems, of course, and how Dante is going to install the NOC now for Giant and your mate. Please, Toby.
So, good afternoon. As Jürgen has introduced me, I am Toby Rodwell. I'm the manager of the Dante NOC. And for the next 15 minutes, and hopefully no more than that, I'll be talking about the design and setup of the new Géant NOC. I'll just cover these points. A very brief introduction to Dante for those who might not be familiar with the company. The motivation for an in-house NOC. The setup and organization of that NOC. And I'll just look at one tool that we use at the end of that, which is the Dante dashboard. Now, Dante was established in 1993, and it was formed by the European NRENs, formed and owned by the European NRENs. That continues to date. Its purpose was to set up and run a European backbone data network. Originally, that was EuropaNet. Initially, Dante was a very small company and only let and managed the contract. But over the years, Dante has got more proactively involved, first designing and then operating the networks. However, until 2009 and the GN3 project, NOCs have always been outsourced. Now, outsourced NOCs have some advantages, in some cases apparent advantages, which include instant expertise, fixed costs, which is a very genuine advantage, a guaranteed service, by which I mean if the service doesn't deliver, then you get some money back, in theory, and finally, economies of scale. Now, these last 2 points, and the guaranteed service, it's all very well to say, well, if they don't meet their KPIs, then we'll get some money back. But particularly in our world of research and education networking, we don't actually want money back. We just want the service. So that's only a very slight advantage. And the economies of scale, I would say that is a real advantage, particularly when you're looking at a 24/7 help desk where very occasionally someone might ring up in the middle of the night and wants to speak to someone on the phone. It makes absolute sense that that service, those operators are spread across multiple networks to get that economies of scale and provide something that otherwise just would not be feasible. Even allowing for those advantages, there are some disadvantages, and I'd say that is summed up as inflexibility. In theory, one has a contract with the outsourced NOC, and therefore it's possible to cancel that contract if they don't deliver. but in practice, it's very difficult to walk away from such a contract. And it is particularly difficult to retask that outsourced NOC once the contract is in place. So if you decide you want to do something differently, you haven't got more money to pay them, so you think, okay, well, what I'll do is I'll get them to do that instead of this. Well, the fact that there's a contract in place and it's all on a commercial basis, it will make it difficult to do that retasking. So with that in mind, for the GN3 NOC, we had a plan along these lines. Set up an in-house NOC for network management and control, outsource a service desk for routine tasks and communications, and procure a trouble ticket system, which was necessary because the existing trouble ticket system was proprietary to the Géant 2 NOC. In late summer of 2008, a contract was awarded to Maglin Limited, UK, an IT services company based in Cambridgeshire. And that contract was for a Tier 1 NOC, or service desk, and also their trouble ticket system. The responsibilities, then, of the Tier 1 NOC, well, they're the first point of contact. New questions, requests, notifications. And they detect and report new network incidents. The Tier 2, they investigate and repair the basic network problems and will configure and upgrade the network elements. And finally, the Tier 3, well, they're for advanced troubleshooting and advanced configuration. Tier 2 and 3 together, the in-house element, we term that the Network Control Center, or NCC. There's the NOC manager, myself, 2 Tier 3 engineers, that's an IP specialist and an optical specialist, 6 Tier 2 engineers, forming 2 shifts of 3, and a system administrator. Our working hours are Monday to Friday, 0500 to 2100 UK local, so that's 0600 to 2200 Central European time. And that includes public holidays with the exception of Christmas and New Year's Day. Outside of these times, there's an on-call engineer. The Network Control Center is located in Cambridge, very near the main Dante office. And here's an internal shot of it. Now, the NCC engineers, then, they're responsible for both Juniper backbone routers and our Alcatel-Lucent transmission and switching equipment. It's a small number of engineers, so all the engineers must be competent in both areas. So when we were recruiting, we recruited for all but one person for the new NOC. We needed to recruit that one person moved across from Dante. So it was quite a large effort in recruitment last year. The qualities we were particularly looking for was enthusiasm for network and an ability to learn quickly, good theoretical knowledge and a desire to understand concepts. That sort of reinforces the first points. NOC or similar experience was important, but not essential. And equipment experience was desirable, but not really expected. And I think in many ways that's a different approach from the way that the IT industry normally recruits, which is just to try to find somebody who's previously worked on that specific model before now. That's what we ended up with. It's worked fairly well. You'll recognize the third from the right, the handsome chap there. The optical specialist is actually moving across to network engineering and planning now. Having spent 6 months putting this, or 6 months ago having put this team together, already my optical specialist is moving on. But within Dante into a better role, so good luck to her. But it does mean I now have to go through the whole process of recruiting again. I said that I want to talk now about the Dante dashboard, a very specific tool to Dante. It was developed by the Dante staff, both in-house and also a contractor to do the actual software coding. And it was required to provide the service desk with clear, accurate, and unambiguous information for new trouble tickets. And this is because it is assumed that the service desk will operate without any knowledge of the network topology. It will receive SNMP traps from, for example, our Juniper routers, the Alcatel network management system, and a few other systems as well. It will, to the extent that it can at the moment, correlate the received alarms and display or potentially update a single alarm on the dashboard. It is integrated with the Dante Ops database in order to generate meaningful and/or friendly names. Some of you might have already seen aspects of the Dante Ops database on the web, as APMs do have access to it. This is an example screen. Not sure how well that's coming across. I have exploded one line at the bottom there. Hopefully that's a bit more visible. Very briefly, working from left to right, The first column, that blank red, I should explain, don't worry, this doesn't indicate that all the alarms we ever have are critical red. I've actually applied a filter here in order to find the alarm of interest. But that first column, red, indicates the severity of the alarm. Broadly speaking, an IP interface or BGP peering going down would be a red or critical alarm, and something along the lines of forward error corrections on an optical path would be a minor alarm. So the red column there on the far left-hand side indicates the initial severity of the alarm. The background colour of the next two columns indicates the current state of the alarm. And the fact that it's green means that these alarms have all cleared. These are actually all historical alarms. The second column indicates the time that the alarm was raised. The third column, headed by the hash, that's the number of times that particular alarm has occurred. And the importance of that is that, bearing in mind that the service desk will only ever react to what they see and follow very predefined scripts, we did not want the same alarm to occur 3 times in quick succession and have the service desk raise 3 tickets. So instead, we'll have that one column increment the number of times that the alarm is seen, and in that way we get an indication of an alarm recurring without actually having the risk of the service desk creating a new ticket. The fourth column is very important. That's the location code. This indicates really which piece of equipment has raised the alarm, and broadly speaking, most NRENs are interested predominantly in only 1 or 2 locations where they have predominantly, say, their primary access peering or their backup peering, or in some cases there might be other locations which are of a particular interest to them. So by having that location code, which the service desk can include in an outgoing incident ticket when it's opened, then NRENs will be able to quite quickly identify whether or not that ticket is going to be particularly relevant to them. Then the fifth column, that indicates that's the actual equipment that raised the alarm. The sixth column is the project, because whilst this is the Géant NOC, the Dante NOC provides for Géant, it also provides for UMed Connect 2, and also provides the end-to-end coordination unit, which I won't dwell on as time is short. But there are those 3 services that we provide. Then I suppose the sort of meat of the alarm is the alarm type, and that is some text which the service desk will basically copy and paste into the trouble ticket. Anything in brackets, so for example on that in this exploded line at the bottom, interface SO600, we ask the service desk to leave that out because that's not really relevant to the NRENs. So the title of the ticket that went out here would be ATDE is down. And then there's a column showing the trouble ticket number, the associated trouble ticket number, and some columns to indicate an acknowledgement by both the service desk and also the network control center. And finally, it is possible to add comments, and that's what that final column, penultimate column is for. The final column is just an ability to select multiple tickets to take alarms to operate upon. And I suppose the only other thing to note is the fact there is that yellow square in the middle. That is a pen tip, a tool tip as it were, that pops up when you loiter over an alarm. That indicates the actual raw alarms which have contributed to that correlated alarm. And I think that was fairly swift. I'm sure that will satisfy Jürgen. I might even have some time for some questions. Let's find out.
Good job, Toby. Thanks a lot. Very good.
My pleasure.
Are there any immediate questions? Yes, please. Can you have a mic? Because of the streaming, we need to connect to the mics.
Yeah.
Thank you.
Hi.
My name is Stefan from Nordernet. I just had one question. The code for your dashboard, I assume it looked like it was something like a web page.
Yes, it's presented on a web page. Yeah.
Okay. Is that code available, for example, to NRENs within Géant?
I would expect so, but I would just have to check. But if you want to leave me your email address, I'll find out and get back to you.
Thanks.
Okay, no worries.
Okay. Anything else for a moment? Thanks, Toby.
Okay.
So the next knob is a quite different one to the 2 presentations we have heard right now. We are jumping over the Atlantic, and Jean-Paul Heron will give us an insight into the global research NOC that is responsible for Internet 2 and NLR, National Lambda Rail, and specifically for operations in the Genie project, which you certainly have heard about. John, please.
Thank you for giving me the chance to jump across the Atlantic. My wife also sends her thanks for giving her the excuse to come over here. All right, good afternoon. So my name again is John Paul Heron. I'm from the Global Research NOC, that is at Indiana University, if anybody cares, in the US. My presentation will be slightly different in emphasis from the last two. I'm going to talk mainly about the topic of interest to us at the moment, which is the Genie operations context, but I will talk some about how we do things generally at the Global NOC, although this is the only slide you'll get to see. So the Global NOC was started in 1998 as the Abilene NOC, which, as all of you know, was the Internet 2 network at the time. So it's about 10 years old. And when I started in 2000, there were 4 network engineers, 8 staff within our call center, what we call the service desk now. So in the meantime, since 2000, we've grown to a little over 50 people altogether across all of the groups. The organization is split into 4 main groups. The first is, as I said, the service desk. These are the people that answer the phone 24/7 by 365. We don't have a phone tree, so we make sure that there's always, if you call, you always get a person instead of a machine. We also make sure that they have instant access to an engineer if you request it, so that you don't have to wait for a call back, so you don't get the typical vendor experience. The service desk also concentrates on monitoring the networks that we support, which are what you see here, verifying problems when they come up, doing some problem aggregation. I think we heard some about alert aggregation from the JAMP folks about how they do that in an automated way. We depend on the people that staff our service desk to understand all of the alerts and combine the things that are really the same issue together before they create a ticket. So it does depend on them having a good understanding of topology and a general understanding of how the networks operate and what parts are what to be able to do that. The service desk also serves as our communication hub between vendors and customers and the engineering staff. So there are about 20 people in the service desk today. There are 3 other teams that report to me. They are 2 network engineering teams that I'll talk about next. What we call the engineering team is the group of engineers that are also responsible for responding to issues on a 24/7 basis. They work a normal 9 to 5 business hour work week, but have a rotating on-call schedule to handle off-hours issues. This team also deals with network deployment, which we do a fair amount of, deploying equipment for various networks, Internet 2 or NLR or others. And they do the basic day-to-day provisioning and maintenance on the network. The second network engineering team we call the network planning team, which really is a little bit of a misnomer. They have 2 functions. The network planning team, first of all, is a specialized team. They focus on a single network or a single area of networks for us. For instance, Internet 2 has 2 people within our network planning team that focus exclusively on Internet 2 projects, one on IP network-related issues and one on non-IP network issues. They work at a higher level on planning and architecture, working with our network owners, the people that are like Internet 2 or NLR that are actually making the architectural decisions. They serve in an advisory and consulting role to them on project planning or on network architecture. And the second role they have is the final point of escalation for any operational issues. The last team that I'll mention that reports to us is a team of software developers and system administrators. Oh, I should mention that we have 8 people in what I call the engineering team that handle the day-to-day troubleshooting. We have 7 people in our network planning team. So our software developers and system administrators, we have 13 plus 2 open positions right now. They do system administration for all of our servers that help to manage the networks and monitor the networks, as well as the measurement systems that are part of the network, like the Internet to Observatory project. They also develop all and maintain all of the code that we use. The vast majority of tools that we use are built in-house, although we do use Nagios for general alerting. We do use a commercial product for ticketing called Footprints from a company called Numara. But most of what we do is built in-house. We have a large database that we use for everything from business tracking, inventory, reporting, things like that, to tracking of circuits and interfaces and BGP sessions. They've also developed tools for us like the Atlas code, which is our new version of the weather map that shows utilization with real GIS information. So the path a problem takes for us when it comes in is usually the service desk will notice an alert. They'll create a ticket and assign it to an engineer immediately. Depending on the criticality of that, it will either get looked at immediately, no matter what time of day, or it'll wait a predetermined amount of time. If that engineer has an issue, they can escalate to the planning team member who is specifically assigned to whichever area is having the problem. So if it's an Internet 2 issue on the IP network, it can get escalated to Karen Litvani, who's our network planning team member for the Internet 2 IP network. So that's where we are today. You can see that there are a number of networks here that we support. This number is expanding. Our future, we heard some about the scaling issues for handling a 24/7 call center, and we see the same thing in the US. And what we've started to see is that people providing regional support, typically using just a pager or some sort of automated wake up an engineer method, are coming to us asking if we could provide after-hours call support or some basic Tier 2 engineering support, with them still maintaining overall control of the network and doing that on an after-hours basis because it's just too expensive to start it up on their own. We already have the scale, and it's incremental for us to add that in. So we saw that with the top left there, which is the Connecticut Education Network. We've just recently added the top right there, which is the MAX Network Mid-Atlantic Crossroads, which is the Washington, D.C. area regional. For them, we're actually providing 24/7 full engineering support, except for that planning team architecture role. So that's all about the general things that we do at the Global NOC. I want to focus most of what I'm talking about today on what we're doing for Genie, which is a project called the Genie Meta Operations Center. So I'll give a little bit of Genie background, talk about what Meta Operations is, what we're trying to do, and some of our challenges, and some of the interesting things that we see interrelating between operating Genie and the future of operations, generally speaking, for production networks. So Genie, as probably all of you know, is a project to support network research, greenfield, ground-up network research. We're building a facility. We're not doing the research itself. I like to think of us as building a test track so that the network researchers can rethink how to build a car. We'll give them the place to test out their car design, but we're not going to actually build the car. Funded by the National Science Foundation, a company called BBN Technologies serves as a project office. They've done 2 solicitations so far. Our Met Operations Center project is part of the first solicitation, along with 28 other projects. And then they grouped the projects into various clusters, each cluster based on a large project that's working on how to develop a control plane for a network research facility. Our project is unique in that it doesn't fit into any of these clusters. We're a special kind of project that has to work with everybody. The principles of Genie is that it's a virtualized infrastructure so that You can run multiple slices. Multiple researchers can have their own virtual network running at the same time. It's federated in that all of these projects have to work together with, there's not a single design that's driving it. It's really driven by the group of projects and what they come up with. And it's evolutionary. So as projects succeed, as they get uptake, as they get researchers to use what they're doing, those will continue to get funded by Genie, and what doesn't get uptake is not. So what do we mean by meta? So coming into Genie, there are a lot of projects, and some of them already do operations. They already have a mechanism to operate their piece of equipment that they're contributing to the Genie project. Some of them don't. So the question came up, what does it mean to operate Genie? Do you need anything beyond all of the different people contributing their piece to Genie? Do you need anything beyond them each operating their piece? Is there a Genie-wide idea of operations? And there are really three options to deal with operations in Genie. One is that it's completely distributed, like I just said. Two would be a very centralized operations methodology. Or three, what we're calling meta operations. So if you take this example here and you have all these squares each represent a project in the Genie project, contributing a set of infrastructure and a set of software. You could have each of those that's just responsible for operating its little piece of Genie, and that's all that there is to operations in the Genie world. You could have some very centralized Genie operations with direct access and control over every piece of equipment that's part of the Genie project. Or you could have what we're experimenting with and what we're proposing right now, which is you have a meta operations center that handles a coordination function among all of those people that are already providing operations to their pieces, as well as providing direct operations to some of the things that don't really have a home today. So our architecture, very quickly, it comes down to having an exchanger to talk to every project, to pull operational data from them. We've come up with a set of minimal data that they should share with us. A translator that says if it's in some format that we don't like, it'll translate it into some format that's consistent across projects, and then a place to keep it. What we're going to do with all this data initially at this stage to test out this meta operations idea, we have two main deliverables to the project. One is a Genie-wide view of the operations of Genie, meaning maps and graphs of Genie as a whole. What's the traffic map of Genie, what's up and what's down right now on Genie. We're also looking at providing that same level of view on a slice-by-slice level, because experimenters want to see, once they build a virtual network, they want to see everything operational about their piece of the network without having to understand the other pieces of what's out there. You know, what's going on my experiment right now, what's up and what's down, how much traffic is there. The other basic function that's been discussed from day one in Genie is this emergency shutdown idea. So this is an obvious case and a difficult one to figure out, but you have all this virtualization technology. What do you do when something goes awry? What do you do when the firewalls between the slices doesn't work as it's supposed to and someone takes up too much? What do you do in a real simple case where someone isn't getting the resources that they've expected, or they have gotten the resources they expect but they can't get into it anymore, and it's frozen them out? How do we identify those and shut down the slices in the best way to keep Genie stable overall and not cut off too much? So our challenges, I've already mentioned this federation. There are lots of projects, all at different levels, with different maturity levels in what they're doing, all with different ideas for what kinds of information they want to share. We depend on cooperation from them all, which is not an easy thing to get. They want to concentrate on their interest, which is never operations. That's only our interest. And so we're trying to strike this balance with Genie between having the centralized tools to provide those functions I just talked about, but still letting people spend most of their time working on their project. Second is, what do we pay attention to? So in the Genie, if you can imagine each cloud here is a Genie project. Do we just look at projects as a whole? That project is healthy or not? There's 100 megabits coming out of that project into Genie. Or do we look at the individual pieces of equipment within each project, what they call Genie components? Or do we look even deeper to that, into the slivers, virtualized pieces of each piece of equipment that are tied together to make these slices? And the answer is yes, we do all of those things, depending on what we can get from the projects. And then there are some general things about just operating a virtualized entity here that make it more difficult. Everything's temporary, things come up and go down. This isn't a typical Internet to IP network where I know that what the connections are and those connections stay the same for weeks or years on end. This is what you're really operating is a series of many networks that come and go for short periods of time. Everything is obviously more complicated. We have all of these groups that I mentioned that we have to deal with in the federated world. We have the research users. Throwing a wrench in things, there's also the idea of opt-in users. So in Genie, there's this idea that network research really needs live traffic to run their experiments on, which means you have to pick out some suckers from the world and who will just run their traffic over Genie. Not that they're experimenting on it, but their normal traffic will just go over Genie so that other people can use their traffic to run their experiments. And everything's more concurrent. So how do you give researchers the view of the piece that they care about and not clutter things up for them with all of what's going on Genie on any given point? So finally, there's a question, all this stuff is very interesting in an academic sort of way, but does it relate to any of our jobs as real network operators? And we've found a few ways that there's a pretty strong correlation between the issues we're confronting in Genie and the issues we're beginning to see in the normal R&E networking world. So federation is an issue in Genie. It's also becoming an issue in R&E. When you have all these multi-domain things being set up, you have end-to-end performance. We all want to work together to figure out how to understand end-to-end performance and how best to work together as on a knock-to-knock federation way to make sure that we're getting the performance we want. Genie is virtualized, and so increasingly our production networks because of these dynamic circuits. All the same things apply to the dynamic circuit world that apply to Genie. We still have to know what the configured state of the dynamic circuit world is versus what's actually out there at any given point, and that may change on a minute-by-minute basis. And that makes things more difficult, obviously, for the people trying to troubleshoot. And lastly, when you're worried about what kinds of things are operationally significant in the Genie world, what do you pay attention to? The same things apply, again, especially in the dynamic circuit world in R&E networking. You have to understand where to pay attention so you don't get too much information, but you don't end up missing operational things either. So that's all.
Thanks, Jean-Paul. Are there any questions to Jean-Paul? There's one, there's another. Okay. Start.
How much of a view do you have inside of all the Genie networks? Because they're managed by all kinds of different parts. How far down does your view go as the meta NOC?
At this point, it goes as far as they have the capability to give us. So if you look, it varies very widely. So if you look at the Planet Lab project, for instance, we get a large amount of visibility. Others don't have anything.
What are your experiences with that? Does it help having that deep down view, or does it?
So we haven't actually had to do any operations on it. We're still at the building it level. So those functions that I mentioned, that the emergency shutdown and those kinds of things, we're not doing that yet. From what we've seen so far, we will definitely need to drill all the way down if we're going to have any hope of automatically identifying misbehaving slices. we can do general operations and see this circuit is overutilized, but we won't be able to see who's responsible if we don't have that level of information.
Okay, thank you.
Just a very simple question, and you probably said it, but your staffing levels for the non-network planners, so those engineers who cover, in the Global Research NOC, who cover everything, how many people are we talking about?
That's 8. So it's 8 people in a rotation of,
Covering 24/7?
Yeah. So I did say this, but I went over very quickly. They work, those 8 work on a normal 9 to 5 and have a rotating on-call.
Oh, right,
rotation.
okay then.
Yeah. We believe actually that if things grow, we'll split that team into 2, so we have 2 on call at any given point. But there's still resistance to doing actual multiple shift among the engineers. So.
Yeah, I'm not sure if European employment law would allow anything like that.
Okay, thanks again. Our next speaker is my colleague Hubert Weibel from the DFN NOC in Stuttgart. You know, DFN has 2 locations, Berlin as a main part, and then we have another group in Stuttgart where Hubert is working on, and he is already 8 years the head of the NOC and was working a little bit longer for DFN, and we both guys are, so to say, the 2 guys missing the 25th anniversary birthday party of DFN, being here at the conference, but it's a pleasure for us to be here. So, Hubert, please, the floor is yours.
Thank you very much. Okay. As Jürgen has said, my name is Hubert Weibel, and I'm working for DFN and there for the Network Operations Center, and there I'm team leader. Today I don't like to bore you with the main task we are having at the Network Operations Center, like configuration management, fault management, and so on. Today I would like to show you some results I've written down, in one of the special topics I'm interested in, and that's IP topology planning. Agenda, first of all, I would like to introduce, in 5 minutes, the DFN and our network, then zoom in to our layer 1, layer 2 topology, and afterwards, go a little bit upstairs to the IP topology, and afterwards, I will show you the results and the problems we are seeing, for example, in a topology planning area. First of all, for those of you who don't know DFN is more or less a shortcut for German research network, and we are a non-profit association. We are calling our networks, or we are naming our networks WIN, Wissenschaftsnetz in German, or the English translation is National Research Network. As you can see here, we had several evolution steps in our networks. It starts with a small band WIN. There were some networks before, but I don't know them because I joined just in the middle of this SWIN, and so the networks before Jürgen knows this, but that's very historical. Well, so we started more or less with the X.25 based small band network, where we had a 2 megabit backbone, and the customers were connected with 128 kilobits. This was replaced by the broadband WIN based on ATM. Afterwards, the G-WIN came around the corner. This was an SDH-based network. We started there with a 2.5 gig backbone. At the end of G-WIN, we had, of course, a bigger one. The lines we had there were STM64 or 10 gig. And yes, we had some customers there in Gwin which were already connected at the end with 2.5 gig. And nowadays we are having, we have the Xwin, that's a WDM network. And this started, I think, 2005, and we are having a 10 gig backbone. At the beginning, customers were connected with 1 gig. And nowadays they are connected with 10 gig or even more, and that's the problem I would like to talk today. But first, let's have a look at our fiber topology. Well, as you can see, it's a very good, and we were capable to set up a very good and a very well layouted fiber topology and get fibers nearly throughout Germany. There were some areas in the upper level of Germany, like Kiel, Rostock, and so on, where we didn't get one. And there we enriched this fiber topology with lambdas to set up our services. Important to mention here, we are not connecting these fibers directly to the router. No, they are surrounded with WDM equipment, and this service is outsourced. So we are getting the fibers from the fiber providers, handing them over to a lambda provider, who are here, and getting back the services we would like to have. And the main stuff which is done with this is, with the lambdas, is of course the IP topology, but it's important to mention here that other services are growing. There are dedicated lambdas, which, for example, two universities are connected, or cross-border links or something like that. This market is really growing, and we have a lot of dedicated lambdas besides the IP topology. That's the IP topology we are using today. And as you can see, it's a very symmetric topology. It's not based on a computational optimization program. This IP topology is set up with some very simple building blocks. And the first one is, using hierarchical design. We had discussions in the past about to flatten more and more this network, but from my point of view, this would have been the wrong decision. And so we introduced a so-called supercore between Hanover, Potsdam, Erlangen, and Frankfurt. This is fully meshed with 2 times 10 gig. And this supercore is more or less responsible for transporting the inter-regional traffic from north to the south, from west to the east, and so on and so on. So the second building block is the follow the fiber principle. And yes, there we try really to ring up the rest of the POPs we are having here in the fiber topology in rings and connect them to the supercore. One example, when you have a look over there is Hanover, and when you go down the fiber road to Göttingen, GOE, then to Kassel, Marburg, Gießen, Frankfurt, this is one such a ring, and yes, the ring is closed in Frankfurt via the supercore. We are having a lot of such rings, which could be very long, and they are shortcutted with crosslinks directly from the supercore to the ring routers, like, for example, Frankfurt, Garching, or Setter, Erlangen, XR Leipzig. And last but not least, the last building block or the concept is about the peerings. In Gwin, in former times, peerings were really spread all over the network. And nowadays, we really try to group them around the supercore. And here in a counterpart manner. For example, we are having 2 upstreams here, Global Crossing in Frankfurt, and on the other side, Telia in Potsdam. Or we are having a DE6 connection in Frankfurt, and the second one we set up, and terminated this in Potsdam. And of course, big peering is here in Geant, and for historical reasons, here you see that that's for historical reason. The telecom peering is still terminated in Leipzig, but in the future we will group them also around the supercore. Customer connections. Our customer connections ranges from, well, 10 megabit Ethernet up to 10 gigabit, or even more than 10 gig, 2 times 10 gig. In the near future, probably 3 times 10 gig. And this is the problem I will speak now or later on. But first of all, let me mention yet another issue here. Not an issue. The customers are connected since the beginning of this year to 2 different accent POPs, and then you can, for example, get a very high availability with this concept. But going back now to the big pipes, for example, University D is connected to an X-WAN router with 2 times 10 gig. This is a problem because in the past one would have said, yeah, well, when you sell at the edge, for example, STM1s or 155 megabit, you have to have in the core, yes, STM4s or 622 megabits. Or when you sell at the edge STM16s or 2.5 gig, you have to have in the core STM64s or 10 gigabit links. Well, but what's the next step after 10 gig? It's 40 gig, STM256. And there are rising several problems when thinking about this technology, STM256. First of all, cost problem. I had a look at the Cisco price list, and well, I haven't found 40 gig for our 7600. It's not supported there. Well, it's supported on the CRS1, but really, from my point of view and my personal feeling, they are very expensive there. One 40 gig pipe, only the router costs are about $1 million US global price list. And that's really very much, or yes, a lot of money. Well, what are the alternatives here? Well, we are using this today, load balancing. We are using 2 times 10 gig in our supercore. Yeah, why not using 4 times 10 gig? No problem. You see here, CRS1s connected with 4 times 10 gig, it's about $140,000. And the cheapest solution is when you connect Cisco 70600, it's about $64,000 US. 100 gig is not supported up to now. And by the way, these are only the router costs, the port costs, not the Lambda equipment and so on and so on. But, okay, then we can use the load balancing and 4 times 10 gig. But another problem comes around the corner, and that's the load balancing problem. In a summary, one can say 2 times 10 gig are not 20 gig. Why? Well, it's because the load balancing is not done on a per packet basis. It's not possible. I asked Cisco this. I asked Cisco, hey, is your router equipment capable to do load balancing on a per packet basis? No. Not the CRS ones. No, it could be that the CRS ones are capable, but not this 7600. Another problem about load balancing is that would be the per packet. Another problem with the per packet load balancing would be the applicational problem. Imagine about packet reordering or something like that. From my point of view, it's not a good idea to do a per packet load balancing. Yeah, but what are the alternatives? It's the load balancing done on a flow basis. But then you have a problem, and that I would like to show you here. Well, imagine you are having 3 big flows. One with 5 gig, one with 4 gig, and one with 7 gig. Nominally, no problem. It's about 16 gig. 2 times 10 gig should fit the problem. No, they don't. What's happening? First flow is arriving on the router and is mapped to one link by hashing algorithms. Second flow is arriving and is mapped hopefully to the other link. But what's happening when the third one is arriving the corner? You're having a problem. And it's even possible to construct an overload situation with 2 flows because of the hashing algorithms. They are using source and destination ports, source and destination IP address, and so on and so on. So when one flow is arriving, mapped to link 1, and the second one is also mapped to link 1, you are having a problem. Okay, but what can be done? University connected with 3 times 10 gig, and the backbone should solve the problem, or yes, the backbone should be big enough to handle all the traffic which could come around the corner from the university. And what's the solution here? The first solution is really you have to ask the customer, what the hell are you doing with 30 gig? And it could be that there is a need. And one need is, for example, how I would like to connect this supercomputer A with a supercomputer on the other side. Okay. But then you have to ask, why should we use the IP topology? It can be done without this IP topology. So, and that's the first trade-off. Isolate the traffic, which do not need the IP topology, and then do it without it. It's cheaper. And what can be done furthermore? Yes, the second what can be done is, of course, debundling more and more these links. For example, we are having universities producing big flows, coming into the X-Win, traversing the X-Win, and leaving it, for example, via the GEON peering. Yeah, so why not connect them directly to the router where the GEON peering is terminated? Debundling is the solution here. Not the big pipe. It's easy. It's an easy solution. You can set up port channels, you can use static routing, the customer is happy, and everything is working fine. But that's paperware. That's not real life. And we try this, for example, debundling all this, and we ask and communicate with the customers, hey, why you are using this? Why do you need this? What can be done in the backbone without the STM256? Well, first let's have a look on the peering side. As I've mentioned, load balancing is not a problem when you have a lot of low bandwidth flows. They are balanced over the links you have, for example. So we analyzed our peerings, and we have seen, for example, that at the D86 and also at our upstreams, well, we have such flows. We have many flows with low bandwidth. So load balancing should be not a problem. So, and what's the solution here then? Okay, we use more and more of these links. 2 times 10 gig, for example, to the 86 from one POP, and 2 times 10 gig to the other POP. It's not a good idea to use more, because imagine that at the 86 we are having 150 peering partners. And if you, for example, would if you would connect the 86 also to Hanover and so on, you would double all your peering partners. Okay, Global Crossing and Telia, our upstreams, no problem normally. And here it's probably a good idea, to set up a second link from Global Crossing to Hanover, and in the counterpart manner in the eastern part of Germany via Telia to Erlangen. This is, by the way, this is a slide out of a working map I'm maintaining, and here you see the OSPF costs, but I realized, I don't see this, and I realized, the OSPF costs are there. Okay, going back, telecom is the same. And the peering, there's no problem with load balancing besides GEANT. I will show this later on. In the backbone itself, well, hopefully we can live in, by introducing more and more of crosslinks and do load balancing between CRS1s, between the supercore and the other POPs. And this will hopefully solve the solution till we get 100 gig or 40 gig Ethernet, cheap ones. Last but not least, we are having some problems with the GEANT peering. We observed, for example, big flows entering from the customer our network, 7 gig flows, and leaving our network via GEANT towards the States. This is not a solution for that, because imagine the link between ZR Potsdam and GEANT. This is a shared link. A lot of customers are sharing this link. And if there is, imagine that there is a ground load of course, for example, 5 gig from all these customers, and an additional 7 gig flow arrives the X-Win, you have an overload situation. And the solution here could be dedicated routers. It's cheaper than introducing STM256 lines. And by the way, yes, this dedicated peering routers can be set up by logical routers on the CRS1. But when you set up this dedicated peering routers, you can play around with OSPF costs. You can directly connect, for example, customers to this peering router, and then more or less debundle the needs inside your core. So summarizing, big customer pipes, n times 10 gig are a problem. The solution, the straightforward solution is expensive, STM256. Hopefully the next step is cheaper, hopefully 100 gig of gig Ethernet or 40 gig Ethernet. And well, doing debundling, yes, solves the situation at the edge, and load balancing is the solution in the core in most cases. Besides, besides again, there we have seen projects with big flows. Thank you very much. Question?
Thank you, Hubert. Are there any questions for Hubert directly? Simon? Wait for the mic.
Hi, my name is Simon Leinen, and I work for the Switch NOC. So we have a different approach to yours, probably. I still believe very strongly in the big pipes and statistical multiplexing, and I think it is a priori, it is advantageous to mix traffic and not to debundle it, as you say, because when you debundle, you split up resources that could otherwise be shared, right, by different types of traffic. So a priori, a network consisting of fat links is can carry more traffic than a network where you split up traffic at the edges and put it into different narrow links. Okay, that's just math. It's just statistical multiplexing that you can no longer do. So I can understand that you think that you want to save router interfaces and tell your customers to split up their traffic, and that you don't want large flows to interfere with other traffic. But I still, maybe I'm a pain, but I still want some data to support whether you are actually saving anything with this or not, maybe. So one thing I have a problem with is you say you want to support these large flows, like the 7 gigabit flow and so on, that doesn't or the 11 gigabit flow, I don't know, that doesn't, that you can't stripe so well using per flow load balancing. Wouldn't it be natural that as the computing world in general and also the supercomputing world is moving to massively parallel systems, that you would see less and less of these huge flows and more massively parallel flows? I think I'm seeing that. I haven't quantified it, but when I look at flows on like a supercomputing center that is connected to my network, I don't see huge flows. I see many nice flows of, I don't know, a couple of dozens of megabits or sometimes hundreds of megabits. I never see these gigabit flows. Do you see these? And I think this would be like the natural long-term evolution. You have these clusters of thousands of machines interconnecting, and why should they funnel everything through huge flows?
We really saw 7 gig flows.
Yeah, okay. And you think that the fact that you saw them is
really
enough
one 7 gig flow.
Okay.
And the other side, what I presented is...
Did it go from DAISY to...
Yeah, it's really cheaper to use dedicated lambdas. For example, if you have a supercomputing center A, and they would like to connect to, communicate with supercomputer B. Do the job with IP is very expensive. Do it without the IP topology is cheaper, of course.
Okay, so this is also something that I sort of chuckled at. You go to the customer and ask them, why are you using the IP topology? It is not necessary here. But the customer, from the customer's point of view, it is the thing that is there. So you're asking them, why do you use something that is there? And why don't you use something that we can build for you?
No,
right?
I'm not asking why. I'm asking what are you doing there? Is it possible to do it in a cheaper manner?
Sure, but I don't understand why you think that. I can't get into this mindset of seeing the IP network as something costly, whereas these lambdas are free. And in reality, the lambdas, you have to build them, right? And you build them, and they are in place, they take up capacity, they are never switched off. Maybe sometimes people use them, maybe sometimes people have 7 gigabit flows over them, maybe 90% of the time they're idle. And it's wasted capacity. And okay, you could maybe you could use the capacity better if you used it for the routed network. It would cost some, but it could be used by other people. So I think the trade-off is more difficult.
Yeah, but it's cheaper, so it's not wasting.
Okay, you think it's cheaper? Okay.
So let me interrupt that discussion at that point and take it offline and have one more question to Hubert, and then we go in the more general part for the last minutes. So, Ralf.
So sorry, it's not a question, it's a remark. And I'm not advertising for Glyph, but in principle, the solution is to reserve lambdas for the purpose you need them. If the supercomputer needs a big stream, he could reserve a lambda for this time where he needs it. And otherwise, this lambda can be used for normal traffic. That would be the optimum solution. And that's in principle what Glyph does, if you think in the future.
That depends on what your business model is. Of course, when you can reuse.
I'm not talking about costs. I'm talking about
normally
research.
me too, but when I go to my boss and say, hey, we have to upgrade our network, he's asking about the money it costs.
So, okay. Let me ask if there is more. If you have more questions to the other presenters as well, also asking the other presenters to ask themselves or the other presenters, I mean, inside of the NOC people, if there is any discussion, probably that would be good in a panel, of course. We don't have the panel, but anyway, we can just use the chance to give the floor also to the NOC guys to ask questions, just for another 5 minutes or so. But of course, if you want to leave, that's fine as well. So any more questions? Yeah, please. Can we have a mic?
Yes, Stefan from Nordnet again. This is not really a question to the presenters per se, but as was said before, this is something that seems to be sort of new for Trina to talk about the actual operation of a NOC. And I think that's really good. I think it's something that is good to be discussed. And within Nordnet, we have very, very recently now started actually trying to communicate between the network operation sensors and comparing what are we doing and how are we doing it, comparing different tools and also procedures for service management and other things that we actually do. Because there's, it seems like, especially within this community, most of the work is sort of homegrown, and there's a lot of small fixes and tricks here and there to create something bigger. And it feels now, especially with the hybrid networks, that it's becoming extremely complex to run all this. So we're trying to get together and see what can we learn from each other. And I was basically wondering, is there anyone else that is sort of talking about this with their neighboring NRENs or other network operation centers?
Could you raise your hands if you support that idea, please? A couple of. Thank you. Okay, I will take it to the program committee. Maybe we can do something. However, it is still the Trina Networking Conference and not operations meeting. So, I mean, to present the NOC work and the way we did it today is, in my opinion, really fitting into that. I'm not sure if your proposal is reaching a little bit farther than that. So
yeah, I was just interested if anyone else is doing the same thing, and then maybe we could you could pull together sort of outside this as well to compare the comparisons, so to speak. So
okay.
If there is anyone that is doing something similar, feel free, if you see me around, to come up and maybe we can discuss it further or exchange contact details. Thank you.
Okay, thank you. Anything else? Yes, please. And please indicate to whom the question is going.
Sorry, my name is Paul Boven from Jive. Not so much a question, but more a short remark. Those big flows you're talking about, they often can be multiplexed over multiple lines, because to make those kinds of big flows, they're often UDP based, and they don't really care about reordering because they take care of them themselves. Certainly the flows that we in radio astronomy or our application generates doesn't care about reordering. We reorder ourselves to get in the right ordering anyway. So we could be split over multiple links.
I don't know if I fully understood what you say. So you are stating that per packet flow load balancing is possible for the application layer.
Yeah, for some big application it is. Yeah. We even use it where we can't have enough capacity on a single line. We use basically Ethernet bonding in the Linux kernel, where you can do this kind of flow packet-based round robin.
It could be. I have no experience about this applications, but I have seen complaints and about applications which are reacting very nervous about packet reordering. We have done this in the past in some areas, and there we had complaints. And of course, that's one side. On the other side, imagine a router is a router of routers. It's a distributed architecture there, for example, on the CRS ones. And if you would like to do per packet load sharing, there has to be a central instance to do this. It's not possible. I asked the Cisco guys. Imagine one link is connected to line card 1, the other to line card 2. If you would like to do a real per packet load balancing, you have to have a central instance who decides, okay, this packet to this link, this packet to this link. This can be done with one CPU router or so, but not with the high-end routers we are using nowadays.
Well, that's why we do it at the endpoint. We already multiplex it there over multiple links.
Yeah.
Well, except of course I now have to hand this mic around to whoever's going to answer, because this is a question to my fellow operators, both on the panel and elsewhere in the audience. And the question is, what thresholds do you respond to with outages on your leased lines? So I ask this question because the TNC2009 NOC, the predecessor NOC, their alerting system was such that nothing below, I think in the region of 5 minutes, would actually be detected as an outage. So that when it was detected and they reported it to the service provider, it was obviously very clearly a serious issue, an outage of 5+ minutes. Whereas with our new system, our dashboard and other systems, we will detect each and every outage. And the temptation is to say, well, particularly because of the effects of even a short outage on, ironically, these large flows and long-distance, high-bandwidth flows, the importance of having very high-quality links. However, we find that we're contacting a service provider every other day to say there was a 2-second outage on the STM16 you provide us, and they come back and say, well, there's no reason for outage. Then we begin to sound like a bit like a stuck record, and they may stop taking us seriously and the likes like that. So I'd be very interested to know what kind of experiences other NOC operators have. Anyone like to comment or suggest?
Rob Evans from Janet. Much the same as yours, really. We try to report outages whenever we can, but when we do for a short outage, report a short outage, they'll just go, we didn't see anything. I mean, it doesn't affect future reporting, so it's not as though they take us less seriously afterwards, which is what you suggested there. But yeah, for a short outage, they'll just go, well, somebody kicked the fibre or something, yeah.
And will they accept responsibility? Will it contribute towards their SLAs for the month, or unless they actually offer an RFO, would they just say?
No, it's just no fault found. Yeah.
Oh, we have 2 more, but then we have to conclude. Jurens and Jeff.
Peter from Belnet. We also do the same. We have reports of every outage, because also before the customer didn't even notice he had an outage, but now more and more the customer notices every outage because they monitor themselves more deeply. So, and also we take it up with telecommunication operator, and yeah, we really press hard, and we keep an eye on which links and which telecom operators are involved, and then we go higher in the hierarchy of that operator.
Yeah, the question is, how do we detect the outage?
We do it with our network management system, which detects every outage. So,
Every minute, every 5 minutes?
or we do it with SNMP, and it's locked in the log, so you can see it that way.
Active or passive?
It's a 5-minute polling, so.
Yeah, you are doing a 5-minute polling, so you can't expect that you have some numbers in the 1-minute range.
Yeah, we see up and down, so.
SNMP reps is okay, but yeah, that's one hand. But on the other hand, you don't get the full picture with that SNMP reps, of course. Second, for example, we are having access lines, Ethernet access lines, which do not have a signaling. So it could be that at the edge, there is a switch from the telco provider and our router, and the link is up and running, and everything is fine. Same on the customer side. But in the middle, something is broken. Nobody realizes this. And then, of course, how often do you follow?
Yeah, we're trapped.
Okay, yeah, but there are no traps.
So I'm Jeff Boot from Internet 2. My response to those issues are much more that more information needs to be shared, because then, when you have these issues, you know why there was a 2-second outage perhaps, or you can actually detect it a little bit more, even though, being able to share more of that information makes it clear what's going on. You don't necessarily have, to contact every single time there's a 2-second outage, and those tools, for sharing that information, I know exactly what you're talking about, they're going to get better over time.
Ralph, you have something important still? That's the last question, please.
Again, no question. I'm a customer, a DISA network operator, and so I would like to know of every 2-second outage, because we see outages on our routers, on our switches, on a log basis of the router. So we see any signal not going through. And we would like to know if it's a problem at our switch or if it's somewhere within the infrastructure. And if you tell us there was an outage, we know it's not our problem, it's somewhere inside.
Okay, thanks a lot. Thank you for your patience, for your interest, for staying so long. Have a quick coffee, and then the next session is in about 15 minutes. Thank you.